Hello everyone, it is I, Chastity White Rose, here with another programming video. And it's been a long time since I've done these programming videos. And so here's the thing. I want to start off this video by showing you something. See, this folder here is my SDL chased image program. So when I click this, notice it does that. That's the program I'm running here. Actually, it's a little bit weird the way it does that because it doesn't. Yeah, yeah, it doesn't have room for the entire text there. That's a little bit of an oversight. So what I'm going to do here, I'm going to open a terminal. I'm going to. Okay, I like to. Well, it doesn't have to be full screen necessarily. I'm just gonna type make. Okay, now notice that's actually very interesting the way it does that. I want to see something. Okay, when I do that, oh, I see. Oh yeah, because what it actually prints is based off of the way it's done. So for example, when I type make, first it builds and runs the program. See, because what the make command that I have configured to do, you can see it's right up here. It does all the compiler flags, and then so typing main runs the program. And then of course it shows some data there. I'm going to show you how this program works here. Okay. What I'm going to do here is yeah, I think I will full screen that, or maybe not. I don't know if it's necessary to full screen the program. We're going to clear the screen here. So when I type /main, that means run the main program in the current directory. I am on Ubuntu Linux, in case anybody's wondering. Now, here's what it does. Notice how it says /main yeah, this is an example. So first of all, here's the text. This is small. SDL chased image written by Chastity White Rose. That's in tiny text. And then here is enter file as command line to display it. Example. It has an example of a command line here. And then progress flag example. Yeah. So you can see what it says. Progress flag example image designed by Chastity after looking at similar images. So this is what happens if you run main with no command line arguments. It does that. Now let's say that we try to do main with the name of a file that doesn't exist, like dude man. Let's see. Okay, opening file name dude man. Could not load temporary image. SDL error. Couldn't open dude man because dude man doesn't exist. But let's copy and paste this example text here. I'm going to copy and paste this. So copy, and then we're going to paste it. So now if I run this command, you see what it does? It literally runs that file. So you might be wondering, how does this program open that file? And how does it do that? Well, here's the genius of this program. Now, I designed that image, that progress flag, I made that thing. So, okay. So first of all, we're gonna look at some code. Yeah, it's really cool how it does that. So this is a program I've been working on. I'm making my own image viewer. Now here's the thing is so it's actually a big program. It has to do a lot. There's a lot that this program has to do in order to really work. So you'll see here, yeah, so it does several things. So first thing it does is it processes the command line arguments. Um, and then let's see here. Actually, let me see something. So, because when you do it, notice how, yeah. So it's interesting how it does that. And then when we run that command, it does that, and it's yeah. Arg count is 2. Okay. So anyway, it processes the command line arguments. It uses the arg count and arg vector or something. So what it does is if the argument count is greater than 1, if it's 1 if you just run the program name itself, it's just 1. But if it's actually, we technically don't even need this line to be right here. I'm gonna move this. I'm going to move this up here. I'm still going to leave it commented out. It's just an optional thing here. I'm going to comment this out because we don't need to actually display the arg count every time. So if the arg count is greater than 1, then it's going to take the number 1, which is number 1 is actually the second, because arg0 is the name of the program, or which is /main in this case. So then it copies that argument into the file name character array. And you see here we have variables. We have a file name char array. So character arrays in the C programming language are a string. You'll see I have width and height variables, and they're not set to anything. I'm not going to go over the entire program because that would take a long time. Like, how does this work? But first of all, here's a basic run over. It takes that file name, like in the case of the progress flag. This was just a testing thing I was doing where it copies that directly into it. Okay, so then it prints a message that it's trying to open that file name. This I'm going to get to later. This is the image init. You're supposed to initialize the image SDL image library. With that, I'm not doing that yet. For some odd reason it works. I'm going to look more into that. Okay, so here we have, this is bitmap temp. Now, bitmap temp is going to be loaded with the image load function. Now, that's part of the SDL image library. SDL image is an extension library that I have installed on my Ubuntu Linux along with SDL. So it loads a file. Now, what it does is it loads it to a temporary file, and then it displays an error message if it could not load it. It does SDL get error to find what kind of error. This is error checking code. There's a lot of error checking code in the C programming language because if you don't do it right, you mess things up and you have a seg fault and your program crashes. You have to reboot your computer and it's just really ugly. So that's what scares some people away from programming. But anyway, then here's what it does is it converts that surface to this format. Now, it doesn't have to be this format to work. However, what I have discovered is that this format works very well for me when I'm trying to edit the pixel of an image. But this program isn't for that. It's leftovers from an earlier program that did something like that. This, it just converts to that format and then it stores it as bitmap and then it frees the temporary surface. Now, if okay, so now if no bitmap was given, it attempts to create a blank image. So here's what it does. So let's try running it. We're gonna do main and see what it does. So it displays that. How does it display this help page? Well, here's how it works. So yeah, attempting to create blank image. So what it does here is, okay, this is what it does. So let's say there's no command line argument. What it does is it will display a message. It will create a bitmap, not from a file since there was no file to load. It will create a red, green, blue surface with that specific format, and it will create of this size. Now the 0 here, that's the flags. You have to look up at the documentation on the wiki to understand this stuff. 32 bits depth, you know, red, green, blue, alpha. So I did all that, and then it string copies the file name into the help page because there is no file name, but the file name string character is used when determining what the title of the window will be later. So that's why we're using that. And then displays this message here, and it uses argv0 as the example here, because that will automatically be whatever the name of the program is. So if we rename main to something else, and I'll show you an example. So we're going to move main to, let's call it frog. Let's just call it move main to frog. So now when we try to do main, it doesn't do anything. But if we do frog, and now see how it does that? /frog. So it takes whatever the current name of the program is that you're running the program, and that's argv0. So that's just something I know from my experience with command line arguments as a computer programmer. But anyway, we're going to remove frog, and we're just going to just main and recompile the program. So anyway, what it does is it creates that. and then it yeah, it displays all that text. Now then, and if after this else statement, regardless, one of these two branches is run. Either there was a bitmap, or there was a let's see here. Okay, yeah. Let's see here. I'm trying to see here. Okay, yeah. It's complicated. I know how it all works basically, but yeah. So, but in any case, whether there was a file that was loaded or not, it will proceed with the program. Now, here's what it does. It sets the global width and height variables with the width and height of the bitmap. They're accessed like this with the arrow operator, which is a weird thing, but you access pointer variables in this way in C. So then it displays the like if you when you see it, you see that it displays the bitmap width and all that and height and all that. So then it will create a window. It will either create a window based off of the generated automatic bitmap, or it will create a window off of the loaded file. So then it will create a window, and so it does all this stuff. I know how you have to be experienced in SDL to know how this stuff works, but then it gets the surface of the window. And then it loads my font. Now the font library, that's something I've covered in other videos, but I may briefly cover it here. So it basically it creates that blank bitmap, and then it opens a window to match that size, and then it loads the font, and then it blits the bitmap, which is a blank, completely black bitmap, because it's set up here that it's all black. In fact, I can change it. So let's say if I want to change this to green, I can make the window be green. See? It looks weird, doesn't it? And why is some of that white text there? Why is that not having a black background, but some does? Well, that's because those different sections of text are written by 3 different functions. And I'll explain that later. But anyway, we're going to just change this back to black, and then it should look normal. Okay, so it displays text, and then it displays this text, but only on the condition that there was only one command line argument, meaning the name of the program. Then it displays that text, and it uses my this one uses a chase font draw string. This is chase font draw string scaled, and then this is chase font draw string scaled color. I know that's a really big long name for a function, but that's what it's called. And then it updates the window surface, refreshes the screen or the surface of the window. And then this loop right here, this literally only exists to make the program pause until the escape key is pressed. So when I run this program, if I press the escape key on my keyboard, it closes. But another thing is if I do the X here, if I click the X, that also has the program. So this code section right here, all this does is it tests for events, and then if there's a key up event, there's key down and key up, but I just use key up because either will work in this case. If the escape key is pressed, loop will go to 0, and if it's an SDL quit type of event, which is clicking the X, then the loop is also 0. So what it does is the loop variable, which is global, doesn't have to be, but it is 1. So while loop is equal to non-zero, and 1 is non-zero, it does that. But what if we set loop equal to 0? Then what happens? Well, we're going to try this. Oh, did you see that? It was too quick. So let's do main. You see how the window creates and it displays the text, but then it disappears? That's why this little wait loop is in here. So it's important to do this in an SDL program. You have to have it keep the window on the screen so you can see what it is. Now this here is set to 0. But okay, and look at this folder here. You see this? There are no PNG files. But if I set this to 1, then it will save the surface to a PNG file. So we're going to do that. And then there's an output.png file. So if we open this, yeah, you see that? We have a PNG file. So the beauty of using the SDL image library is that it has support for PNG images, which is just awesome. So technically, I could have just had my bitmap help page be an actual image file that's loaded. I could have done that too, but I didn't do it that way because I just didn't feel like it. Okay, so we know how the program works. And then after it does all that, it frees the memory. It frees the font surface. It frees the bitmap surface. It destroys the window, quits the SDL system. Now, I do want to briefly show, see, the SDL chased font surface, this is my own port. This uses software surfaces, this particular version here. And it has my chased font structure, has the width and height of a character, and the surface, which is the load font. So I've covered this in previous videos, but it's just worth mentioning that all of this is my own code. It tries to load a font, which is itself a bitmap file. It doesn't load, it only loads bitmaps because that's the way it was written. And I always use just a plain bitmap file. I don't use the SDL image library specifically. And then it converts that font file to the same surface as the screen. It's what it does, which works just fine. So it does a lot of stuff. It checks, does all the error checking, see if the font could be loaded, and then notice how it does main font equals font 8. That's because main font, I use a global main font variable, which is actually defined here. So whatever main font points to, main font and its associated variables are used when it comes to actually drawing the text. So here's the first one. It draws a string of characters at this string S and the character X and Y position where it starts. So all it does is it goes through each character and it does a little bit of math. It figures out that the X position of where we're drawing to is going to be the current character value of that particular letter minus space. It's just the math used to get the right character, and then it sets the source rectangle has to be based on the font image. So let me show you the font image. If we go to font, you'll see that these are all in ASCII order. They're all in ASCII order, with the first character being a space, then it just goes all. So all we're just doing is we're just doing some math to quickly know that it has to go to a certain spot in the font image. And the font image has to work specifically that way. It just works that way. But yeah, so then it will get that particular character, and it has to set up its source, which character is copying from the source image. Then we have to set up the destination, the rectangle for the destination. Okay, where on the screen is it drawing this character to? And it's set by these variables. So it's a complicated function. It probably needs some cleaning up, probably needs some clarification, but it works. But it draws at the same size as the original image. And then it does it scaled. So you can this one scales it to any size, but it's still using a blit scaled operation. So it's just, yeah, it's still a blit. Whereas this one can do different colors. It's capable of doing different colors. It's a lot more complicated because it directly accesses the pixel values of the source font image. So it does all this stuff. It sets up a lot of things. The basic same idea, except that it's kind of complicated. It's hard to explain. I understand how it works, but as it says, now for the ultra complicated stuff that only Chastity can read and understand. It is complicated, but it all makes sense. We have a source rectangle where we're copying we're going to be copying a certain character. But what it's doing is it's going through all the pixels in that particular area. So it's reading the pixels from the source image. It's taking that 8 by 8 section of that whatever character it is, and each one is going through, and so it will do this. If the pixel is black, it will skip over this. But if the pixel is not 0, if it's not black, then it will do all this stuff. It'll set up the rectangle to draw to, where we're gonna draw a rectangle. It's based on the scale. I'm not sure anybody will understand what I'm doing, but it draws a square according to the scale. So if there's a single pixel that's white in the source image, then we can have the scale value. So we could have like 20 be the scale, and it will draw a 20 wide by 20 high square to match that pixel. So it scales. So this is my own invention. It took a long time to get the code right. Like, you have no idea how many hours, but it works. And to prove that it works, here's what we're going to do. What I'm going to do is I'm going to go to the part up here where okay, draw. Yeah, so first it's doing that. So we're going to change this. We passed the color white to it. But let's say we want to make the color cyan instead. Let's do this. Okay, let's try. You see, I made it cyan. I can do that. And if I want to make it yellow instead, we could just do this. It works. I can even make it orange by doing this. So that function is what's actually used to scale and modify the color. So it's really the only function I need, but there's multiple different ways that my font library can work. They all draw text, but this is the only one that draws color. So, you know, not only did I write my own image viewer program, but I also added my own font library. It's the same font library I used in Chastris, actually. Only this is a special SDL port. The original was in Raylib. So anyway, here's what we're going to notice is that, okay, now notice that this is commented out. Now, it still loads the PNG file. So here's the thing. When we do this, we're going to do, okay, we're going to do main. Okay, it loads the image. And see, it's obviously PNG support is already working. Obviously it's working. But I'm not even initializing with image init. So here's what we're going to do. Okay, so this is normally you would try to initialize it with PNG support. Okay, yeah, I need to recompile the program. So we're going to do that. Okay, then we're going to run it. Yeah, it still works whether I do it or not. Now, what happens if I change this to 0? Even when I initialize it with 0, it still works. So here's the thing. Here's what I'm going to do, though. I'm going to comment this out again. And I want to make sure I'm using this function correctly. Here's what I'm going to do. I'm going to make a copy of it there. I'm going to get on the internet and look at the SDL wiki. So here's what I'm going to do. First of all, I go to libsdl.org. The documentation is not very good because they haven't updated it, and I mean, they're not being paid either. It's open source. People do what they feel like. They have not made the documentation complete. So here's what I'm going to do is let's go to additional libraries, because I'm using an additional library. So here we have okay, let's go to the project page for SDL image. These are the image file formats that it supports. There's a lot of really cool formats. So we're going to go to the project page here. Okay. Let's see here. Actually, it's not showing this very well. That's weird. Okay. Okay, documentation is also available on. Okay, so here it is, the wiki page for the SDL image library. So we're going to be going to category API. So what we're going to do is we're going to go to the image init. So this function here, okay, initialization flags ordered together returns all currently initialized flags. This function loads dynamic libraries that SDL image needs and prepares them for use. This must be the first function you call an SDL image, and if it fails, you should not continue with the library. Okay, flags should be one or more flags from image init flags ordered together. It returns the flag successfully initialized or on failure. So it has all of these different things. So here's what we're going to actually do. We're going to I'm gonna have to do a little bit of test. So first of all, we have a variable in this program named x. We just use the variable x for a lot of things. I love the variable x. It's like what I use. I usually have it at the beginning of a function. So here's what we're gonna do is we are gonna initialize it with png. So okay, x equals this, and then okay, I need to do printf. Okay, let's take an existing printf statement that opens a it prints an integer. Okay, so here's what we're gonna do. We're going to, let's see, where is it? Okay, so what we're gonna do is we're going to do okay, so image init equals, okay, it's gonna be x. Okay, we're going to do that. We're going to compile and rerun this program here. Okay, let me make sure that, okay, I am recording. That's good to know. Okay, so we have this. We're calling the function. It may work for me with added on Linux, but who knows when I go to Windows if it'll still work. Okay, so it does the same thing. The behavior hasn't changed. Okay, so so let's see where, yeah, where, okay, that's strange. Yeah, that's bizarre. Okay, where does it initialize the image? Okay. Oh, wait a minute. Oh, I noticed something. Notice this initializing code was, okay, it was done, it needs to be done at the beginning of the program. Okay, it can't just be because this is only in the branch if the arg count equals 1. Okay, so here's what we're going to do. We're actually going to yeah, we want to do this at the beginning of the program. Or actually, it doesn't. Let's see here. This program doesn't even seem to call SDL init. First of all, where is init? Did I not initialize SDL? Okay, that is an error. Okay, what we're gonna do here is at the very start of the program, after we, okay, I'm going to initialize image init. We're just gonna do that. Okay, let's see here. Image init equals 2. How interesting. Image init equals 2. That's cool. So now let's try something. So now let's try, what if it is 0? Okay, image init equals 0. It's very bizarre because okay, I see. So okay, yeah, that's very weird. Because then it's 0. So it's probably not a big deal. It's probably not. Because it is working for me. So it's actually, well, actually, wait. We need to know for sure that it's working. Okay, so we're gonna try, because image init is not loaded with anything, it still loads it. So apparently, now based on what it says, it loads dynamic libraries. So what I'm guessing is that it still works. That means that the PNG library is statically linked. So in that case, it works. But okay, so what we're gonna do here is yeah. So we're just gonna initialize that. We're totally gonna initialize that. Okay. So it's good to initialize it anyway. It's good to do it, even though it may not be required and it still works. It's probably good to do it just to make sure that we don't run into any errors. But see, I found an error in my program during this video this way. So that way, even if it's dynamic, we still guarantee it'll be loaded. So, but since init is only in that place, only those places. Whereas, okay, what I'm going to do is I'm going to go over to SDL chase just so in my Tetris game, and I made a Tetris game, people, just so you know, because I try to make that clear. So at the beginning of a program, we have, okay, that one, yeah, we don't need to look at this. Okay, so this is what happened. This is, we're going to just use SDL init. Okay. I'm going to copy this. So first of all, it okay, there we go. So we're going to initialize SDL. So, all right, because it's good to do that just to make sure it works. Okay, SDL could not be initialized. So it will only do that if something goes wrong. But at least I'm including the initialization code. Okay, so yeah, so it works. All right, that's good. That's really good. It works. And then, yep, it works. So the program still behaves the same way, but I made sure the initialization code is in there. Because if I'm running on Windows, it might try to dynamically load the PNG support. Now, of course, there are other formats, obviously, including WebP. I don't know much about WebP. It doesn't even see what I mean. There's no documentation on the WebP format, but more flags may be added in a future SDL image release. Okay. Okay. So yeah, let's see here. Okay. Let's see here. Okay, yeah. Yeah, so it's fine now. Image quit. Let's see. Deinitialize SDL image. This should be the last function you call an SDL image after freeing all other resources. This will unload any shared library it is using for various codecs. After this call to image init will return 0. No codecs loaded. Okay. Okay. Okay, so even though it's probably not necessary, I'm going to do it. So what it's going to do is, before it tries at the very end of the program, before it tries to, okay, I'm going to delete this one. I'm going to close that file. We're going to go back to this file. So what it's going to do is, it's going to, okay, it's going to quit. Okay, I want to see what happens if I put it at the end. Actually, what happens if it says void? Okay, wait, let's just try this. Void. Okay, yeah, void means that there shouldn't be anything there. Okay, we're going to do make. It still works the same. But yeah, so it's going to, after everything else is considered, it's going to close image quit, and then it will quit SDL itself. It's an extension library. So Okay, so this program it initializes the video portion of SDL, and then it tries to initialize PNG loading, and then it does all this stuff, and depending on whether there's a file name given, it either displays a help page or it will display the image you give it. It can load other files as well. So, like for example, so we've seen, okay, we've seen like that. So just plain main displays the help file. Okay, it's not actually a file, but okay. And then we're trying to do this. It works like that. But here's something else we can do. Let's say that we wanted to display the font file. Then what we're going to do is I'm going to copy the name of this file here. I'm gonna try something here. It's gonna be font slash, then we're gonna paste. It doesn't work, right? Because because there's a space in the file name. So that means we have to put this in quotes when a file name has spaces. Oh, interesting. It couldn't open. It's interesting that it could not. Oh yeah, because it has to have the extension .bmp. It's a bitmap. Okay, see, now it works. See how it has this tiny window? It's a super tiny window, and it's just big enough to display that file. So it's based on the size, but the title bar thing is actually bigger than the image itself. So that's the thing. So it works with a bitmap, it works with a PNG, and all I really care about, I like bitmap because it loads faster. I like PNG because it's compressed and saves space. Those are the only two formats I personally care about. And my program loads both. So as you see during the course of this video, I have made sure that my program can successfully it can load and display bitmap and PNG file. It's an image viewer. It actually works. It's amazing. It works on. I've tested it before on Windows actually, though it was a little bit different. So here's what I'm going to do. Now that I have ensured my program works, and it's funny because oh wait, I'm in the wrong folder. This is the wrong folder. Oh, that's my Tetris game. I accidentally launched my Tetris game. It's funny how that is, yeah. Because see, I came to this folder to copy the initialization code, but just so you know, see, this is SDL Chase 2. It's my latest version, so it compiles and runs this. I made my own Tetris game, and the game is so great it plays itself. Like you can't play it yourself. And I published this on Steam. Though the version I published on Steam actually had music, and it was made with Raylib. But yeah, that's my Tetris game. So I made my own Tetris game, and I made my own image viewer, and I made a few other games too. So let's go to, yeah. Actually, there's a lot of really weird stuff I did. I actually tried to make my own Pong game. Now, it doesn't have any input, but yeah, I tried to make my own Pong. And what's interesting about this particularly is that if you watch this Pong game I made, it's automatic. The bumpers on the side, they automatically follow the ball, and the ball always moves in the exact same way. So it repeats the same thing over and over again. I have not added the ability to control it, meaning the ability to fail. I haven't added that in yet. So that's kind of funny. But yeah, I did try to make my own Pong. It needs a lot of work. It's not perfect. And I don't think I'd be able to sell it. That's part of why I haven't made it a priority. I don't think I could sell a Pong game. There's plenty of versions of that. Okay, so let's exit out of there, and let's look at another game. Let's look at okay, let's see. Let's see where was, yeah, chase panel. Okay. Yeah, this is another game I made. idea. That's a game I made. There's another game I made that I made in Raylib. I haven't ported it over to SDL because there's not much point. But I did make this other game, Chase Puyo. I'm just gonna show you this as an example. You get the idea. It's my own clone of a Puyo Puyo game. Anyway, that's enough demos. I showed you my 3 published games I made. All these games are published. You can buy them on itch.io, as well as on Steam. There's also Chase Triss, which is really cool. But anyway, I'm very glad I did this programming video. Now, the final step I'm going to do, actually, I want to try something. I'm gonna make a slight change. So first of all, okay, there's my desktop. You see, okay, here is okay. Let's see. I want to look at my display settings here, cause background. Let's see here. I want to add a picture. What I'm going to do though is I'm going to make sure I don't mess anything up. I'm going to take my, okay, so here's my SDL Chase image program. We know this is the one here. Yep, it works. Okay, so we're going to take this file here. I'm going to copy it into my documents, because I have a okay, actually my pictures, because I know that somewhere in here I have pretty sure I have a wallpapers place. Actually, it's in my home directory. Where is my wallpapers? I could have sworn that I had a yeah, because where's that one image stored? Yeah, that's weird. Oh, I have, yeah. I'm not even sure. Okay. I honestly, I don't even know. Let's see here. I'm, okay, yeah, I'm confused because I know I had okay, let me do a search for wallpaper. Because I thought I had a folder of wallpaper. Oh, actually. Oh, cool. Here is, oh, yeah, some official Tetris wallpapers. Oh yeah, it's some official Tetris 99 wallpapers. I totally could use those. Those are cool. Very cool wallpapers. But what I'm just gonna do for now is I don't even know this file. I don't know where I put it. I really don't know where I put it. We're just gonna go to the display settings, and then I'm just going to add a I wish I knew where that was located. Okay, but I'm just going to add to this. Yeah, so where's SDL Chase? Okay, so we're just going to make the progress flag be yep, the progress flag is now going to be my desktop background. That is so cool. It is so absolutely cool that I made the progress flag be my background image, because you know, Pride Month. So, and then the final step I have to do before I end this video, I'm going to go to my GitHub. So I have a GitHub for like all my projects. A lot of these are private, some of them are public. So SDL Chase image. So now that I've updated the source, what I do is whenever I actually access this, like this batch file here, I look at this batch file. This is a Windows batch file. I use it to compile and run things on Windows, so that's why it's there. So I upload that from Windows, and then I download it onto Linux just as backup. So anyway, we're in the source folder of the STL chased image. So chased image is my own image viewer. I name everything chaste. It's kind of my root word of my name, chastity. So we're going to go to, I don't have this one add to the shortcut, so I just use one of my others. Okay, so we're just going to make sure that these files, now the README file, I haven't updated the README in a while. Yeah, actually, let me see what the README contains. I want to see. Okay, let's go to, what does the README contain? Okay, yeah, it's a little bit of an explanation. Um, this was an earlier thing. Um, I don't know if anybody will use my. I probably need to update it because I had an older project named STL Chased Bitmap, which is very interesting, and in fact I can show you that real quick. So STL Chased Bitmap was very similar. So if we go make here, it does that. It loads the progress flag, but you'll notice that it was a bitmap file. It has a PNG file, but it was an actual bitmap file. Look at the difference: 6.2 megabytes of bitmap versus 35.1 kilobytes as a PNG. Obviously, the space savings with using PNG files is immense. But this is in this older version of the program, which is it's messed up. New version is better. It does load BMP, which is a built-in STL library function. But anyway, that's enough of that. So now that I've updated the source files and I've made sure the only one that actually changed was main.c. That's where all the changes happened. And that's the process. So I fixed some errors on the program, made sure the initialization code was working in there. I commented out a few things. That is a perfect example of the kind of programming I do. So now I'm going to end this video, and then I'm going to share it all over the place so I can show people what the actual process looks like. And I hope that my explanation made sense to some people. So I'm going to end this video, and I'll guess you guys will see me later.